Hello students, welcome to the 12th episode of our example problem series for Circuits 1 here at NDSU. In this episode we are going to cover phasors. Now, in this specific example, we're only going to be able to solve this circuit using one method, KCL probably. However, all of the previous circuit analysis techniques that we've learned also apply to circuits using phasor representation, which is exactly what we have. Let's go over it. Here we have an AC source of 18 volts at an angle of negative 90 degrees in series with an impedance of negative J400 in parallel with an impedance of J100 in parallel with an impedance of 400 ohms in series with another AC source of 12 volts at an angle of 0 degrees. As I said, we're going to solve using KCL. Let's draw our node. Just call that V1. And let's write the equation for it. What do we have? Oh, forgot to draw my arrows. We're going to sum out. Important to keep things very clear. We have V1 minus 18 at an angle of negative 90 degrees plus V1. Oh, we forgot our impedance over negative J400 plus V1 over J100 plus V1 minus 12 at an angle of 0 degrees over 400 equals 0. All right. Now we have numbers with angles attached to them, and we have numbers that are multiplied by J. Let's try to simplify those. To do that, I'm going to draw the imaginary, or the J-axis, and the real axis. Ooh, ever the artist. I'm going to make this look pretty ugly. Real axis. Okay. Now, the voltage 18 at an angle of 90 degrees, negative 90 degrees, excuse me, can be represented as a vector with magnitude 18 at an angle of just that, negative 90 degrees. However, since our imaginary axis is the J-axis, this is equivalent to negative J18. So let's rewrite our equation with just J's in it instead of these angles. V1 minus a negative J plus J18 over negative J400 plus V1 over J100. That one's fine. We want it like that. V1 minus 12. Now similarly, at an angle of 0, we just have 12 over 400. No J's involved. Equals 0. And then we can use a little trick to get rid of those complex denominators. What I usually do is try to pick out the denominator that looks the ugliest. I see here on the left that we have a denominator that has a negative J and a constant. Compared to the other ones, that's a little bit more ugly. So that's what we're going to use. We're going to multiply everything by negative J400. It's a little tip. That will give us here negative J400 just cancels with negative J400. We're going to get V1 plus J18. Next, what do we have? The J's cancel, negative stays, and then we have 400 over 100. That's going to give us negative 4 V1 plus, and next our 400s cancel, but the negative J stays. We're going to get negative J V1 plus J12 equals 0. All right, awesome. This looks familiar, right? Now let's clean it up. It's going to give us negative 3 V1 minus j v1 equal to negative j 30. Skipped a few steps, but it's really quite simple. From there, we can factor further. Plus j equals negative j 30. And v1 is going to be equal to 3 plus 9j. Let's put that in polar form. Let's go back to the angles that we just tried to get rid of. It's going to be approximately 9.5 at an angle 71.6 degrees. All right, awesome. Everything that we've covered so far still holds true for phasors. Thanks for watching.